So graphing from vertex form practice, was that slide 13? I believe. Okay, let's look at the next slide. I think this is the actual the last slide, but we're going to do it before we do the others. Effects on the quadratic parent function notes. So y equals x squared is called the quadratic parent function. A transformation is a change to the size or location of a figure. We have the quadratic parent function y equals x squared. If it's written in vertex form, we can use the a, the h, and the k to determine what the transformation was. So the a is the number out front. This is going to change how it's drawn. So like this way would be if it's positive. It'll be upward. Or it'll be downward if A is negative. And it also determines how wide or narrow it is, how fast it goes up. So this would be changes how wide or narrow. It is. H moves it from left and right. And then K, it translates it up and down. All right, so what we are going to do is we are going to graph each of the function, identify the A, the H, and the K, and then determine how the graph is changed. We are going to compare it to the y equals x squared. So let's first identify what the A is on here. What is the A value? What would be out front? Not 0, because then that would make that go away. Yeah, it's going to have to be 1. I really should have put it here. A equals 1. So will there be any changes to it? Wideness, narrowness, or flipping? Upward, downward? It'll still be upward. And then same width as the y equals x squared. Okay, let's determine the h. So remember yesterday when we did the formula? X minus h squared plus k. So what is the h going to be? -2. Let's not write what it's going to do because I want us to graph it and look at that first. And then what's the k value? Positive or negative though? -3. Now go to y equals, and let's put in our parent function so we can compare it. Y equals x squared in the first y1. And then in y2, we are going to put the other one. We don't have to put that one out there because we can, it's imaginary. It can stay there or not. So parentheses x plus 2 squared minus 3. So y1 and y2 should be on your y equals page. Okay. Hey, graph. Let's look at them. Let's compare. So the first one that's graphed, the blue one, is y equals x squared. And then the red one is our new function. So let's think about the 2. Remember what HK is? Y'all remember that's our vertex? HK. So our vertex is -2, -3. So let's look at what the -2 did to our function. So the original, the parent function, is the blue one. So how did the -2 affect it? It moved it to the side. So remember how we said H translates it left and right? Which way did it translate it? Okay, so left 2 units. Or I'm just going to put left 2. And then what about the K? How did that perform some kind of transformation? Then down 3. Whenever we look at this function, though, see how this is a +2 and this is a -3? A lot of people want to say it's going to go right 2 because of that +2. But you got to remember that the vertex form is x minus h. It has a built-in minus in there. So you got to be careful with that. So it went left 2 even though this says x plus 2. And the reason is because it's x minus h is our formula for vertex form. And then the down 3, that's from the -3, from the k. All right, let's go to the next one. A value. What's the a value? -1/2. What's going to happen to our function because it's negative? Yep, it's going to flip. So I'm going to put flip, and then you can just draw it if you want. And then what do you think the 1/2 is going to do? Is it going to make it wider or narrower? Narrower, you think? Okay, wider. Okay, so we really need to look at it. Let's go ahead and write what the h is. What is the h value? This says +2, but our formula says -h. So what is it? -2. So what's going to happen to our function? How is it going to be moved? Yep, left 2. And then what's our k value? 0. Okay. All right, let's go ahead and graph it. We'll keep the y equals x squared as our y1. Let's clear out the other one. -1/2 x plus 2 squared. Hit graph. So it does flip over. It does move to the left 2 units. And was it made wider or narrower? Wider. It was actually made wider. Yep. And whenever it's wider, it's actually it's increasing slower. Think about if you are multiplying times half compared to multiplying times 5. If you multiply times 5, it's going to go really fast. So it's going to be narrower. So whenever you have a number less than 1, it'll be wider. So let's go over here. Wide will be when A, the absolute value of A, because we're not talking about positive or negative, but less than 1. So I put absolute value in there so we don't even think about the negative. We just make it positive. So half is going to make it wider. And then the absolute value of A being greater than 1 is going to make it narrower. The vertex on this is HK, so negative 2, 0. And is that true here? Negative 2, 0. Okay, you're going to go through this with your table group. And what I want y'all to do, complete the table to make an accurate group of the quadratic parent function, y equals x squared. Create the table, create the graph. And on each one of these 5, it gives you y equals x squared as your parent function. And I want you to graph y equals y2, which on this one's negative x squared. And then I want you to compare them. Hold on. You will compare them over here on this next one. Summarize observations below. So you're going to talk about what was the effect and what is the domain and range. So there's actually 7 of these I want you to do. Okay, so go ahead and do this with your table group.